Hello, my name is Matthew Kimler. I'm a senior technical architect with Integrated Archive Systems, and today I wanted to run through a demonstration that we built at IAS to show how Ansible could be used to spin up EC2 instances in AWS and leverage NetApp's SnapMirror technology and Cloud ONTAP technology to take data that we have residing in our on-premise data center, replicate it up to AWS, and then leverage that data for our EC2 instances. So a way to burst into the cloud using our own data on-prem. So what I've set up in my EC2 environment is I have my Ansible controller. We also are running NetApp's Cloud Manager and our NetApp ONTAP Cloud environment in EC2, which I'll describe a little bit later. But we have our controller, which is where we're going to be doing the majority of our work. So we have Ansible installed on this particular system, and just to kind of run through the process that we'll be doing today, we're going to be running a playbook to deploy our EC2 instances and create those based on the configurations that we requested, we want. Our AMI does not include Apache, so we're going to just quickly show how you can deploy Apache quickly and get the services up and running for that. Then switching over to the NetApp side, showing you how we can use RAW commands to actually just pull basic information from NetApp, whether it be for reporting or just for information gathering for playbooks down the line, which is also similar to what the snapshot information playbook will be doing, so we'll show you that. Then we're going to actually be leveraging NetApp's modules for Ansible to actually perform a clone operation and then ensuring that that volume that we cloned is read-writable and is set up as an export volume. We'll move on to then, now that we have our volume set up in cloned, we're going to mount that NFS volume on each of those EC2 instances, and then we'll just do one last configuration change in the environment to allow that NFS volume to be used for our environment. So let's dive into these. So the first one is just looking at our playbook. We have our provisioning of AWS resources. So this is us creating our EC2 instances. And what we're specifying here is a bunch of information around our region, our AMI that we want to use, our VPC information, our access keys. All this stuff has been placed in my the group vars variable all file. So all the private information is in there. And then specific information about what we want the AMI, the EC2 instance to be set up as. So we have our volume sizes, and then we have the number that we're going to be deploying. In this particular case, it will be 3. And then lastly, important for our demo is we're specifying some tags that we want to be applied to our EC2 instances. And the reason that we want to do this is specifically so that we can use dynamic inventories based on tags to manipulate those instances, so that we're not making changes on all EC2 instances, but only ones that have certain tags. So we're applying those tags right to the environment. So with that said, we're going to actually go run this playbook right now and get those instances stood up. So the speed at which EC2 or AWS will spin these instances up is a variable. It depends on how fast the request is handled by Amazon. Typically, this process for 3 instances has taken me anywhere from 10 seconds to a minute being worst case scenario. But it doesn't happen too often. But I should, if I hit the refresh here, I should see that I actually already see them coming up. So they've actually started to deploy. So this should be, and now it's already complete. So if I swing back over here one more time and hit the refresh button, there we go. We have our 3 EC2 instances that we spun up. And if I take a look at the details, I have my public IP address that I actually said that I wanted to get. And I have my tags that I specified. However, if I go to one of these and let's just punch this guy up, there's no web services running at the system. There's nothing running here to present. There's no web services running. So at that point, the next step for us would be to run, get Apache installed on those systems. So this is a very simple playbook to essentially get HTTPD installed and then started if it's not. We also have a way to kind of just confirm that Apache is not actually running on this. What we did is built a manual command just to run a shell to look at the processes running on the system and see if there's any that are matching HTTPD. And then specifically wanted to specify here that we're actually using we're using the inventory of the EC2 Python script for the dynamic inventory, and you can get this from Amazon. But it allows us to specify, all right, we're going to be using this EC2 Python script to use it as a dynamic inventory, and our host in the playbook is actually specifying the tag that we were looking for. So the first part is saying, all right, you want to query a tag. The second hyphen is the actual name of the tag, or the key that you want. And then last is the value of the tag, so demo. So tag is the name that your tag is the type of thing that you're querying for. The environment is the key, and then demo is the actual value. So that's how we're actually kind of looking for these. So if I hit the enter on here, we can see that, all right, we looked at the processes on all three systems here, but HTTPD is not showing up on those. So the next step here would be to actually run this playbook. So let's run this playbook. Again, specifying the dynamic inventory of the EC2 Python script, my particular YAML file, and then I'm using a key file just for security reasons, so that to do any work on this, you have to specify the temp file. So let's run that. And it should get Apache installed on there. In a couple of seconds. Typically no more than 10. Oh, there they go. And now it's going to start the service. And now if I go back and I run that command one more time to look at the processes, I should see, yep, I see Apache is now actually running on each of those systems. And if I go back over here, I should be able to hit the refresh button, and there's the default generic page. Okay. So let's just clear this, and let's look at our list again here. So the next thing I wanted to show is kind of switching from the Amazon side is going over to the NetApp side. So as one of the solutions offered by NetApp is a technology called ONTAP Cloud, which allows customers to spin up ONTAP environments, NetApp ONTAP environments in Azure or AWS, and manage and build relationships actually between those cloud versions of ONTAP and their ONTAP that's running in their on-prem data center on, like, say, a CDOT system. So what we've done is we've deployed Cloud Manager, which runs actually as an EC2 instance as well in our AWS environment. This is all deployed actually by this cloud management interface. It actually does the deployment, the configuration. You just need to give it the EC2 information, and it does all the work for you. And then from there, we were able to actually add our on-prem ONTAP environment. And from there, we can see actually all of our volumes that exist on our on-prem data center. There's quite a few. But we also were able to spin up the AWS version of an ONTAP environment and build a relationship between the two. So this second environment is actually this EC2 instance running in AWS. Excuse me. And so from that, we were actually able to build a snap mirror relationship between these two. So we took a volume that we have on our on-prem data center, which has some images that I would like to use in my my web environment up in EC2. In the example of a burst, we need to burst to the cloud, for example, for DR purposes or just for scaling. So we have our on-prem data. We've replicated that to the cloud environment, and we can see the status of that from just clicking on this replication status. So we see our relationship here. We're taking this source volume, RHS Ansible, and the target is the copy, and we can see the the status of the replication and what the frequency is and all those details. And so if I actually go into this environment and click on it, I should actually see a couple volumes, and one of those will be actually that copy. But it is a SnapMirror copy, and we can't actually, this is a read-only copy. We can't make changes to it. So what we want to do is actually make a clone of that to work with. So let's swing back over to our Ansible controller here. So a few things. As I mentioned, we can run we can use Ansible to run commands on a NetApp environment in two different ways. The first is we can actually use it to run raw commands, which is really just the the dirty SSH command. But if for some reason there is no module for NetApp, you can always just run a raw command to do what you need to get done. So in this particular case, I just wanted to see, hey, what version is the actual is the NetApp excuse me, is the NetApp running in the cloud? And in this particular case, we can see that it's running 9.4. So simple, just example of how you can use raw commands on a NetApp controller that's on-prem or in the cloud. But I think more interestingly is looking at let's running some raw commands and some modules. So in order for us to make a clone of a volume in NetApp, we need to first identify which volume, which snapshot I'm going to actually use to clone for that volume. So we have a lot of different there's a lot of different snapshots based on the configuration that we have set. There's weeklies, there's dailies, there could be hourlies. And in this particular case, what we've come up with is a way to use a raw command to query the actual volume of the environment, of the volume that we're looking to clone. We're going to do a grep to just kind of pull the weekly snapshot info and then go through some further filtering so that we can trim down some of the results to just get the name of the snapshot that we'll be using, and then write that to actually our group vars all file so that we can save it for another workflow downstream. So let's run this. So what we'll do is run our Ansible playbook. We can see that it contacted our NetApp controller in AWS. It looked at the particular volume and pulled the only two weeklies that I have, and then it trimmed out what we were looking for and just got the last weekly that we're looking for, and then wrote that to the actual file. So that allows us to take it to the next step, which would be to clone it and use that snapshot information. So switching over from the raw commands, we're now going to leverage modules as well as a raw command. And so let me kind of walk through this. So NetApp actually has a lot of modules that are published as part of the Ansible package. So if you are, at the time of this writing, it was Ansible 2.7, or sorry, this demo is 2.7. There are a lot of modules that are available as part of the package for NetApp. In fact, NetApp has the most modules available for Ansible out of all of the storage vendors. So if you look at them, you'll see that they have the most, and they're in constant work. And there's a team really dedicated to kind of building more value around Ansible and NetApp. So these are just getting better and better, and there's just getting more and more of them. So really great ways to use Ansible to manage your NetApp environment. But in this particular case, we're going to be leveraging two modules for the NetApp. The first is the volume clone, which is actually going to make our clone of our SnapMirror copy. in the environment and give it a name called demo clone. And we're going to take that latest snapshot information that we pulled from the previous playbook, and we're going to pull that from our group vars all file and use that to determine which snapshot we'll be using for this particular clone. Then we're going to set an export policy for the NFS so that we can actually, partially, mount this. And then the last is we have to switch back to a raw command only for one little piece, and that's because the current module for volume clone does not actually include a configuration setting for setting a junction path, which is important if you actually want to mount the volume. This is a work in progress, and the team knows that this is currently missing and has been slated to be included at some point. But this is definitely set to be included in a future release. But for now, we're just going to run a raw command real quickly to set that junction path. So with that said, let us run this one. Playbook 4B, and let's run it. So we're going to make that flex clone. We're going to set the export policy and then set the junction path. And we swing back over here and we hit the refresh button. We should now see another volume that we just spun up, that we just made the clone of. There's our demo clone name. And if I take a look at this, I can actually look at the mount command and I can see that I have my export set and ready to go. All right. So we have that set. So let's go back to our list here. Okay. So we have our volume cloned and we have our EC2 instances, but now is to get the EC2 instances to use that NFS mount. So let's take a look at our next playbook, which is mounting that NFS. So this one's pretty straightforward. We're going to get NFS client tools installed if they are not on those EC2 instances. We're going to make sure there is a mount directory that exists for this actual NFS mount, and then we're going to go mount that volume that we just created. So we have another command here that I'm going to run before I actually execute on this, which is again going to just show that the volume did not exist before I actually ran the playbook. So this is again just another manual command just to look for that particular mount volume, but it's not on those EC2 instances. But let's just continue and run this playbook. So again, playbook, running the dynamic inventory because we are again using our scrolling up here, using our tags to identify which systems we're going to be running on. So let's just run that. Okay. All right, so NFS is now installed. We made sure the mount directory exists and the volume is now mounted. If we run our manual command real quickly again and take a look, we can see, yep, each one of these systems now has the demo clone volume mounted as requested. All right, so this is great. We have each of those systems now has the volume with our images, but we haven't really done anything with Apache to say, hey, can you, go use these files? If I try to go to actually the virtual path that it should be at, it's not working. And that's because we haven't really made any changes to the configuration file for Apache. So the last step here is just to make a quick change. We actually put a HTTP conf file in the actual clone volume. So we want to take that source and copy over the existing one that exists today. For Apache to use NFS volumes as a directory, a virtual directory, you have to make a security change to the system. So we're just making a quick Apache config change to allow that to work, and then we're going to just quickly restart Apache one more time to get this to work. So let's execute our playbook one more time, or this last playbook. We'll make the copy change to the configuration file. We're going to change the permissions and restart Apache. And then if we swing over here one more time and hit the refresh button, there we go. We get our IIS banner page here, which is our image that was existing inside of that environment. So that completes the demo for this. Again, showing you how you can use Ansible to do a lot of different things, but in this case, spin up EC2 instances, make changes to them, use a dynamic inventory based on tags. Also how Ansible could be used for NetApp ONTAP systems. If you're interested in that part, there's a lot of information, again, available on the Ansible documentation site for 2.7, which has all of the modules that are currently released. And there are more being added all the time, and so keep an eye on it for what you might be looking to do. And in our next demonstration in another video, I'm going to show you how we do this whole entire process in Ansible Tower, which is actually the graphical version of Ansible by Red Hat, and also it could be built as a workflow. So all of this, even though this could all be one big playbook, show you how you can tag multiple playbooks together in Tower and do this all in one simple click. So with that said, thank you very much for your time. A special thank you to Robert Nelson, who is another technical architect here at IIS, who assisted me with the actual development of the playbooks. And thank you to Red Hat and NetApp as well for their assistance on developing this demonstration. Thank you. Have a great day.